Alright, so I have 2 to the power of 20 minus 4. So what I'm first going to do is I'm going to rewrite 2 to the power of 20 as 2 to the power of 10 times 2. So now I have 2 to the power of 10 times 2 minus 4. Now, if I have something in the form a to the power of m times n, this is the same thing as a to the power of m to the power of n. So 2 to the power of 10 times 2, that's going to equal 2 to the power of 10 to the power of 2. Now I have this minus 4. Now 2 to the power of 10, that's going to be 1024. So now I have 1024 to the power of 2 minus 4. Now 1024, I can rewrite this as 1000 plus 24. So now I have 1000 plus 24 to the power of 2 minus 4. Now, if I have something in the form a plus b squared, this is equal to a squared plus 2ab plus b squared. So in this case, a is 1000 and b is 24. So this is going to equal 1000 squared plus 2 times 1000 times 24 plus 24 squared. Now I have this minus 4. Now 1000 squared, that's the same thing as 1 million. Now I have 2 times 1000, which is 2000, and 2000 times 24, that's going to be 48,000. Now I have this plus 24 squared, which is 576. I have this minus 4. Now 1 million plus 48,000 is 1,048,000. So I have this plus 570 minus 4. 570 minus 4, that's going to equal 566. So I have 1,048,000 plus 566, which is 1,048,500 and, sorry, this isn't 570. This is actually 576. So I have 576 minus 4. So I have 1,048,000. 576 minus 4 is 572. So 1,048,572. So this is my answer. Alright, so in this problem, I have x to the power of 6 minus x to the power of 3 is equal to 2. So to solve this, I'm going to first start by subtracting 2 on both sides. So now I have x to the power of 6 minus x to the power of 3 minus 2 is equal to 0. Now, I'm going to rewrite x to the power of 6 as x to the power of 3 to the power of 2. So I have x to the power of 3 to the power of 2 minus x to the power of 3 minus 2 is equal to 0. Now, if I let x to the power of 3 equal to the variable y, I'm going to have y to the power of 2 plus y minus 2 is equal to 0. Or sorry, y to the power of 3, or sorry, y to the power of 2 minus y minus 2 is equal to 0. And if I factor this, I get y minus 2 times y plus 1 is equal to 0. So this gives me two solutions. Sorry, two equations. I have y minus 2 is equal to 0, and I have y plus 1 is equal to 0. So for y minus 2 equals 0, y is equal to 2. And for y plus 1 equals 0, y equals negative 1. So now remember how we set y equal to x to the power of 3. So if y equals 2, then we have 2 is equal to x to the power of 3. Meaning x is simply equal to, I'm going to take the cube root on both sides. X is equal to the cube root of 2. So this is one solution of x. Now, if y is equal to -1, then I have x to the power of 3 is equal to -1. So now to solve this, I'm going to add 1 on both sides. So I get x to the power of 3 plus 1 is equal to 0. Now, x to the power of 3 plus 1, I can rewrite that as x plus 1 times x squared minus x plus 1 is equal to 0. So this gives me two equations. I have x plus 1 equals 0, which is simply means x is equal to -1, which is one solution. And I have x squared minus x plus 1 equals 0. And to solve this, I actually have to plug this in the quadratic formula, and I'm not going to waste your time doing all of that. But the two solutions I get of x are, I get x is equal to 1 plus or minus the square root of 3i over 2. So these are my four solutions to this problem. Alright, so in this problem, I have 2 to the power of 3x plus 2 to the power of x is equal to 10. So if I have something in the form a to the power of m times n, this is the same thing as a to the power of m to the power of n. So 2 to the power of 3x, we can rewrite that as 2 to the power of x to the power of 3. So I have this plus 2 to the power of x is equal to 10. Now, I'm going to go ahead and let the variable y equal to 2 to the power of x. So if I replace y with if I replace 2 to the power of x with y, I get y to the power of 3 plus y is equal to 10. Now if I subtract 10 on both sides, I get y to the power of 3 plus y minus 10 is equal to 0. Now all we have to simply do is factor this. And y here, I'm going to rewrite as 5y minus 4y. So I have y to the power of 3 plus 5y minus 4y minus 10 is equal to 0. Now I'm going to factor this in groups. I'm going to factor y to the power of 3 plus 5y and also negative 4y minus 10. So for y to the power of 3 plus 5y, the greatest common factor is y. So I get y times y squared plus 5. And for negative 4y minus 10, the greatest common factor is negative 2. So I have negative 2 times negative 2y plus 5. Times 2y plus 5. And this is equal to 0. Actually, instead of doing that, what I'm going to do is I'm going to rewrite this as y to the power of 3 minus 4y plus 5y minus 10 is equal to 0. So I simply just switch these two places. And now if I factor this, I get y times y squared minus 4 plus 5 times y minus 2 is equal to 0. Now y squared minus 4, that's the same thing as y plus 2 times y minus 2. So I have y times y plus 2 times y minus 2 plus 5 times y minus 2 is equal to 0. Now if I factor out y minus 2, I get y minus 2 times y squared plus 2y plus 5, and this is equal to 0. So now this gives me two equations. I get y minus 2 equals 0, which means that y equals 2. And I get y squared plus 2i plus 5 is equal to 0. And to solve that, we'd actually have to use the quadratic formula. So let me go over here. I have y squared plus 2y plus 5 is equal to 0. Quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. So in this case, this would be b is 2, so I have negative 2 plus or minus the square root of b squared, which is 4, minus 4 times a, which is 1, times c, which is 5. And if you notice, actually, 4 minus 4 times 1 times 5 is the same thing as the square root of 4 minus 20, which is equal to the square root of negative 16. And you can't actually take the square root of a negative number, meaning this is wrong, and our only